Hi everyone, welcome to my YouTube channel Techie Code Buddy. I hope you all are doing extremely well and your placement preparation is also going well. Well guys, first of all, if you are new to this channel or haven't subscribed this channel till now, then do consider subscribing this channel as this really motivates me to make more such content for you and for your placement preparation. Well, in this video, what we are going to do? In this video, we are going to solve two coding questions that is recently asked in Accenture exam. Okay. Now, while seeing Codeforces here, don't think that the question is going to be very difficult. No, it's just a pretty simple question. You just need to understand some instructions and you will be able to solve this question. Okay. So don't think that if it is on Codeforces, then it is going to be so hard. It's not so hard. It's not pretty simple, but okay. It is easy to moderate level. Okay. If your coding skills is good, then you will find it easy. And if your coding skills not that much good, that you will find it moderate level. But the question is super simple. I will properly explain you each and everything. And for the next question as well, I will explain you each and everything. Okay. But before proceeding further, if you are not part of our Telegram community, then make sure to do join our Telegram community. The link for the same is given in the description box. Okay. So let's start with the question now. First of all, let me take the pen. Okay. So yeah. So the question is colorful stones. Okay. And this is recently asked in Accenture exam. I think 2nd September it was asked. Okay. So there is a sequence of color stones. The color of each stone is one of red, green or blue. Okay. So there will be a sequence of stones and the color of the stone either can be red, either can be green or it can be blue. Now you are given a string S, the ith, and this string is going to 1 based index and the ith character of S represents the color of ith stone. If the character is R, G or B, the color of the corresponding stone is red, green or blue. Okay, so RGB represents for red, green and blue respectively. Now, initially a squirrel list is standing on the first stone. You perform instructions one or more times. Then each instruction is one of the three types, either red, green or blue. So the string pass is also red, green and blue and the instruction string is also in color code red, green and blue. Okay. Now, after an instruction C, if list is standing on a stone whose color is C, list will move one step forward. That means you will be comparing the first string character to second string character, that if they are same, then list the squirrel will move on to the next stone. If they are not simple, then list will stand only that stone she was standing on, right? So the question is just this. Now you are given a string t, the number of instruction is equal to the length of t and the ith character of t represent the ith instructions. So basically there will be two strings. The first string will tell you the color code or we can say the color of stones. Okay. And it will contain either R, either G or either B. Okay. Or we can say the collection of these characters, that string will contain these. Now the second string will also contain R, G, B, but this is string for instructions and we have to compare that whether the given instruction is equal to the color code or is the stone color and the instruction color is same. If it is same, then we have to move forward our squirrel, and if it is not same, the squirrel will stand on only that stone. Then we will need to compare it with another instruction. If that is same, so squirrel will move forward, but if it is not same, then squirrel will stand on the very last stone and it will look for the next instructions. Okay, so this is going to be our process, what we are going to do in this code. So let's understand the further idea of this. So this is the first input RGB. So this stands for the very first string stands for the color of stones and the very second string stands for the instructions. Okay, so and the output is 2. So there is no any explanation, but I will tell you the how this output is coming. So this is our string S. Okay, this is our first string, that means R, G and B. Now the second string, that means T string, and it is stands for instructions, so it contains only R, R, R. Okay, now first of all what we have to do, we have to compare whether this instruction is having the same color code of that or not. Okay, so we will be comparing that R is stands for R only. Okay, so our squirrel will move forward. Okay, so first time the squirrel was standing on this, that means squirrel position was 1 and here 1 based index. Okay, so squirrel was standing on first stone and we found that the color of stone and the color of instruction is same, so our squirrel will move forward. So squirrel is now here. Now this instruction we have visited. Okay, so we will come here. Now we have to compare this color code with this instructions. Is G equals to R, or we can say if green is equals to red? No. So our squirrel will not move forward and our instruction has been visited, so we will move forward in the string, in the T string. Okay, now we are here at this instruction, but our squirrel is only G, right? So we will be comparing that whether G is equals to red. So again, it is not equals to red. Okay, now we have done with this also and we have completed our instruction array. So we will not forward. So what is the last position of our squirrel? So our squirrel was in second index, right? As the array, or we can say as the string index starts from 1 in this question, so our squirrel was on 2 index, or we can say second position. So the output is 2, right? So let's take the example for this color code. So what is this color code? This color code is, just a minute, R. Okay. So first of all, our squirrel is standing or sitting here at first position. That means on R. That means on red stone. Now, first of all, we will compare whether red equals to blue. So no. Okay. So we have visited this instruction, the first instruction. So we will move forward, but our squirrel will not move forward because they are not same in color, right? So we will move forward in the instruction string, right? Now we are here, but our squirrel is here only. So it will compare whether red equals to blue. So again, no. So we have visited this instruction as well. So we will move forward in the instruction string, not in the stone string. Okay. Now our squirrel is only here at one position. Now it will compare for R equals to B. So again, this is false. Okay. So we will again have been visited with this and we will move forward in the instruction string. Now we are here. Okay, we are here, so we will compare R equals to R. So this time this is true. Okay, so this will move forward if it is true, if stone color and the instruction color are matching. So we have to move forward our squirrel. So our squirrel is this time on second position. All right, now we have been visited with this also, so we will move forward and we are at here R and our squirrel is here. Okay, so it will compare with this R equals to R. So this is again true. So our squirrel will move forward by one step. Okay, now our squirrel is on third position. Okay, our squirrel is on third position and we have to tell that at the very last time, at the end of the day, where is our squirrel? So squirrel is on third position. So the output will be third position. I hope you get the idea. I hope you get the logic. Now let's see the code part of this. So now let's code it. Okay, so first of all, what we are going to do, first of all, we will be taking the input, okay, of string. So we will be taking the input of string. We will be declaring the string S and T. Okay, the very first string for stone colors and the very second string, that means T, is for instruction. All right, now we have to take the input of S and T. Right, now first of all, what we will do, we will take an index for T wali string. Okay, we will take index and we will initialize it with 0 with T wali string and we will just a minute, and we will initialize the starting position of our squirrel as 1. Okay, as it was standing on the very first row. Now we will be traversing in array of instructions. So what we will do, I equals to 0 to I is less than T dot size. Okay, T dot size and I plus plus. Now we will be comparing that if the instruction string character is equals to the stone wali strings character. Okay, then if it is so we will have to move forward our squirrel. So we will be incrementing the case value. Okay, and then what we will do, we will move the pointer of instruction string. Okay, as we have to visit the next instruction. Okay, and at the very last time when we have done with this, we just have to return, or we just have to print the k value. K value is that where is our squirrel now. Okay, so let's run this code for these input output. Okay, these input output are the same as Codeforces. So first of all, run this output. Okay, so all have been done. So this gives us output 2, this gives us output 3, and this gives us output, this is not giving any output. We have not, I think, run it. So just run it again. Okay, so this gives us output 15. Okay, so we have given the input output same as the Codeforces. Now let's check whether the output is matching or not. So the first output was 2, the second is third, and the third output was 15. So whether it is matching or not. So okay, so this is 15, and we have previously saw that this was 2 and 3. Let's run it again. So it is giving us 2. Now let's check for this. Okay, so this is the required code for this. Now let's dry run this code for first input output. Okay, so that it will be better easy for you to understand properly. Now this string for stone color string, this is the very first string. Now this string for T string for instructions. All right, now from here we are taking input string. Now k equals to 1, that is the initial position of our squirrel. Now what we will do, we will be comparing the each character of our T string with the character of our stone string. Okay, so first of all, as we are comparing with T string, so first of all I equals to 0, that means we are here. Okay, we are here. Now we will be comparing whether I is less than T dot size, so T size is 3 here, so 0 is less than 3, so condition is true. We will come here in the for loop. Now we will be checking if the first character of, or we can say at the 0th index character of T string is equals to the stone color string. So if R equals to R, from here we are comparing now. So yes, it is true. So we will move forward. What we will move forward, we will increment the position of our squirrel. So our squirrel will go here, and k pointer is only here, so it will go here. Okay, so k value is 1 now. Okay, now j plus plus. So what J stands for? J stands for color code wali string. So J will move here. So J is now on G. Okay. Now again the I value will be incremented. That means now we are here at the second instruction. So 1 is less than 3. So the condition is true. Again we will check whether R equals to Z. So this time this is not true. So we will come out of here. So again the I value will be incremented. I value is now 2, and it will check R equals to V. So this condition is again false. We will come out of the loop. Okay, and here I value will be incremented, and it will be 3. So 3 is less than 3, so condition. So what we will do, we will out of the for loop, and at the last time we have to return the kth position. So k is on second position. At the last time k is on second position, so 2 will be the answer over here. I hope it makes sense. I hope it is clear to you. I hope all the things are easy for you now. So now go and code it. Okay, and I will put that question and this code in the Telegram community. So make sure to do join our Telegram group. So yeah, let's move on to the next question. Okay, so now favorite number of Rohan. Rohan enjoys mathematics and has a few favorite numbers. Therefore, Rohan prefers positive integers whose sole lucky digits in the decimal notation are 4 and 7. Okay, so that number that will contain 4 and 7 solely, that will consider as a lucky number. For instance, lucky numbers are 47, 744, whereas unlucky numbers are 517 and 467 now. You might be thinking then why 467? Because we take it solely, so it will give us 6 as well. So we don't consider, or we can say Rohan don't consider 6 as a lucky number. So this number will not consider as the lucky number, right? Now, if a number can be divided evenly by a lucky number, Rohan considered is to be almost lucky. Now, he needs our assistance to determine whether the supplied number n is nearly lucky, or we can say almost lucky. So we have to find out how many numbers are there, or we can say what the number that is considered as a almost lucky, not properly lucky, almost lucky. What are some numbers that can consider as almost lucky or near to lucky, right? So what we will do, first of all, we can say that Rohan like only limited numbers that can consider that will contain only either 4 or 7, or we can say 4 and 7 mixture, right? So what can be these numbers? First of all, let's find out what can be these numbers. So let me take the pen. So what can be these numbers? This can be 4, this can be 7, this can be 44, this can be 47. Yeah. So there are total 12 numbers that can be considered as totally lucky. These numbers are totally lucky as they are solely contain 4 or 7, or we can say combinedly contain 4 and 7. But they are all made up of 4 and 7 only. So these numbers will be considered as totally lucky. Now, what we have to find it, we have to find out nearly lucky. Now, what is almost or nearly lucky is if a number is properly divided by, or we can say completely divided by, or else we can say evenly divided by either 4, either 7, either 44, either 47, or we can say in simple terms, if a number is completely divided by either of the number that is in the array of lucky numbers. So we can say that this number is almost lucky. So yeah, that's done. This is all about the question. Now, uh, what we have to find out, we will first take the input, then we will check for then we will check for that input whether this number is divided by either this. Okay, we will check one by one. So what we will do, we will be traversing the whole array of this, right? We will be comparing one by one whether this number is divisible by 4. If it is not, then we will come here and we will check whether it is divisible by 7. If it is not, we will check whether it is divisible by 44. If it is not, then we will move forward, move forward, move forward. Okay. So if the whole array of lucky numbers will be traversed and we will find out that the number is not divided by either of the number in lucky number array, we can say that the number is not going to be nearly lucky or almost lucky. So we will return 0, and if it is lucky, then if it is almost lucky, then we will return as 1. Okay. So now let's code it. Okay. So the code is pretty simple. I will tell you the whole code. Okay. To save the time, I write down the code. Now, first of all, this is our header file. This is the namespace standard. This is the whole function that will tell us whether the number is almost lucky or not. Okay. So first of all, let's see what is this. What is this doing? Just a minute. First of all, we will see what is this doing. So in the main function, what we will do, we will first of all input our number that we have to check for whether it is almost lucky or not. Okay. So if you are doing this question in your exam, in your Accenture exam, so you don't have to write this, enter a number and so on. Okay. Now you will be taking input. Now this is the condition. If the number is almost lucky, so what we will have to do, we will have to print that this number is almost lucky, otherwise we will have to print that it is not almost lucky, right? Now here we are calling our function is almost lucky, and the whole work will in the this function. Now, so first of all, what we will do, just a minute, sorry for the interruption. Okay, so here this is our function. This will return either true or false. This is why we are taking return type as input. Now the function, and here we are passing our input number, where we have to check for that whether it is almost lucky or not. So we have already initialized, or we have already declared our array that it will contain only these numbers. Is there any possible combination of 4 and 7? No, na. Only these number will be considered as solely lucky, right? Now we have done with this. Now what we will do, we will traverse this array. Okay, we will traverse this array, and the size will be, we can find out the size of lucky numbers divided by size of the first index. So we will find out that the size is what. Okay, so from here we are checking, we will be one by one comparing whether this number is divisible by any of these numbers. So what we will do, we will do and modulus. This will return us the remainder. If the remainder will be 0, then we can say that the number is completely that we can say that the number is almost lucky. Okay, if the number is divided by the lucky number, then we can consider is that almost lucky. So from here we can find out. Okay, so suppose I check for this 361 whether it is almost lucky or not. Okay, now what will I do? First of all, I will pass this number as 361. So the function will start to work. Now this is the array. Now for int I equals to 0 means our pointer is here on 4. Right? Now I is less than the size of this array. So yeah, 0 is less than 12. Yeah. So n modulus lucky number. N is 361. 361 modulus 4. Right? So I will divide 361 by 4. So let's divide it here. 361 by 4. So the remainder is 1. I got the remainder as 1, and here we are comparing whether the remainder is 0 or not. So here I got 1. So the condition is false. Okay, so the condition is false. We will move forward and I value will be incremented. Now I will check whether 7 is dividing 361 completely or not. So we will check out from 7. Okay, from 7, 361. 7 5 35, 1 1. Now again the remainder is 11, so it will move forward. The condition is false. Okay, so it will move forward. So this is how it is taken again and again. If there is a number that divides 361 completely, so the 361 can be considered as a almost lucky number. But if it is not, and we have done with the whole traversal of our lucky number array, so we can conclude that your given number is not the lucky number, right? Or we can say is not the almost lucky number, right? So this is how the code is working. Now let's take some input output for this. Okay, almost lucky or not. So yeah, it is almost lucky. Now let's check for 361. Okay, 361. So 361 is not almost lucky. Now let's check for, I can say 567. Just a minute, 467. 467. Okay, so it is not almost lucky. So this was a full code. Okay, I hope the question is clear to you. So yeah, that's all for today from my side. These both questions are asked in recent Accenture exam. I hope the questions are clear to you. I hope you got the idea. So let's meet in the next video. Till then, bye bye and take care. Keep preparing, keep exploring. Bye.